Hello everyone, this is Arunan J. Bharati from Carbon Figure Academy. In this video, we are going to have a full-scale demo of lifecycle assessment using Eco Chain Mobius LCA tool. So if you want to have a brief introduction on the same tool, you can go back to our channel and you can find that under the playlist of product lifecycle assessment. Right. So in this video, we are going to have a sample product called AAC block, that is autoclaved aerated concrete block, which is a construction product usually being used for masonry construction, right? The wall construction, right? So before proceeding into the tool, this is how you should prepare your entire life cycle inventory based on the boundary condition that you have. So typically in this video we will cover the entire possible life cycle modules except the use stage. Yes, with respect to AAC block, there can be an account for the impact happened during the use stage also. So if you want to understand more on how to come up with the data which is required to model the use stage, you can go to the EPD International, or you can go to LCA websites where you can find the relevant PCRs and complementary PCRs, right? So there you will be able to find what are the scenarios that you should consider while modeling the use stage for concrete and concrete related elements, right? So in this video we will start with A1, then A2, then A3, then A4 and A5 we will have. Regarding the downstream, there won't be the transportation, but still we can simply add that, no issues. And excluding the B stage, which means use phase, we will straightly jump into the end of life stage, C module, and we will also cover the D module, right? So likewise, you need to work in the background and you have to build this kind of inventory before proceeding to the software, right? So because the softwares are like timing out, right? So when you are opening the software in a web browser and you do the calculation parallelly, means sometimes you may take more time. The software will become timed out. So right, so sometimes your previously entered stuff would be saved automatically, sometimes it may not happen. So it is advised to build this entire life cycle inventory first, following whatever the required calculation you need to do regarding the unit conversion or proper unit, everything. Then bring this kind of a table and then you jump into the software, right? So let's go to the software, Eco Chain Mobius. So once you purchase the subscription, either it is monthly or yearly, based on your requirement, you will need to log in here, right? ecochain.com/login. So you can see two different products, Eco Chain Mobius and Eco Chain Helix. So in our introductory video, we have clearly described what is the purpose and when to choose which type of tool, whether it is Mobius or Helix, which one you really need to choose. I have detailedly explained there, so you can check that introductory video of Eco Chain. So here we are going to use Eco Chain Mobius. So I just click there. So I think it is just let me through, since I have recently logged in. Yeah, here it is. So this is your home page. So first of all, what you have to do is, in the right top corner you see workplace settings. That you just click, you can see certain informations. So here it is where the impact assessment methods are decided, along with what are the databases that you want to see while looking for the background data set during modeling, right? So you just click that, you will be able to select them, right? So here we are going to use the EN15804 plus A2 method, and impact assessment method. If you see, So the same thing, but still based on some previous versions of environmental footprint. So currently it is EF 3.1. So we chosen that, and preferred databases you can check. So currently both 3.9.1 and 3.11 is there. I really don't understand why they skipped 3.10. Maybe some technical description would be there in the behind logic, but still we don't want to go into that. So available databases are Eco Invent, but two different versions. So if you want to stick with only one database, which means one version, you can choose that, right? Or if you want to go with with the different versions, then you don't need to select here. Then normalization weighing, right? So you have options to go with that normalization and thing with respect to EF 3.1, but still we are not going for that. And impact category, obviously every impact category will be shown up, but for the visual immediate interpretation, one impact category will be shown. So which one that you want to be. So that's what the climate change total, right? And single score, no, because if you choose that normalization weighing, then it will be activated. And excluding long-term impacts, yes. So what is mean by that excluding long-term impact? Sometimes when they calculate the impact under different categories, they may need to come up with the time frame of calculations. It's 20 years, 50 years, 100 years, 500 years, like that. So typically it is being agreed to go with 100 years impact, the values. There is no scientific background behind that choice of 100 years. Why specifically they want to measure the impacts only for the 100-year lifetime span? No, there is no such things. It's just being agreed. Maybe I personally believe that might be the reason that the humans, those who are assessing, and they can do some counteract measures within their lifespan, right? So that's why they stick with that 100 years scenario. So that is what is being mentioned here. If you don't exclude the long term, it will calculate for 200 years or 250 years. So those numbers are quite low compared to the 100 years, but still there is no such real intention behind, because post 200 years what is the impact, if you want to know, and you want to do some counteractions now, then there is no proper connection between them, right? So it is being followed to exclude the long-term impacts and stick with that 100-year scenario. So that's what is being taken into account here. Okay, I want to exclude the long-term impacts, so I just save it, right? That's it. So the workplace has been set up. Now you just have this kind of dashboard. So they have their kind of template life cycle assessment, like see different sectors and different products, and you can scroll down to see, yes, lot of them are there. So once you open them, for example, coffee cups, okay, use a template. So they are coming up with the template and they are just asking whether you want to use it. Okay, let's use it. I'm just showing you what are the things are there in the dashboard, but there is no connection between this and our sample product, right? Okay, can you see that the entire the things of that coffee cup is being here, right? Yeah, let me minimize them so that you can have some overall picture. Okay, so can you see that? Yeah, Okay, right. So here you can see 1 unit of paper cup. So the product is what? Disposable coffee cup. So how they build the inventory for the PCF, and they splitted that coffee cup into different components. What are they? One paper cup, second one is paper lid, then third one is packaging material, then fourth one is production process, right? So under that paper cup, what are all the materials are there? So adhesive, bottom disc, inner coating, outer coating, paper stock, and printing ink. So all these elements went into that. Once you break down it, you can see, yeah, non-toxic ink has been added. So likewise, based on the split up of your components in the product, under each of the component, they added the respective inventory. That's it, right? So this is like, you may ask, there is no life cycle stage, nothing, right? So this is a typical PCF, normally considering the cradle to gate scenario. So only the material and the manufacturing inventories have been added. If you want to add the upstream transportation, you can add. So what about the paper cup? What about all these raw materials from where you brought up all these separately, and you can add that A2. So then it would be like cradle to gate completely, right? So insights, if you click, yeah, here it is. So the contribution wise impact they mention, and you can export the results into PCF report or Excel or as a inventory. So let us put this, because this is what people normally like, whether your tool will generate the report or not. Yeah, here it is, the coffee cup. Okay, it is not quite a report, but still it is one page kind of summary, right? But we need the full-fledged report, right? I think it is only there. Why it is not showing any report? Okay, let's click read more. Okay, only export. Yeah, but oh, okay. Here it is. Yeah, the top right corner, you see the tools. Here you see translate, download PDF. Let us click here. I think the same is coming up again. Yeah, but once I really downloaded a full-fledged PCF report, maybe this is what to say, the sample product. I think it is not coming up, maybe, right? So that's how you may use, or maybe I might not able to find out where to download it exactly. I'm not sure, so sorry for that. Okay, so this is how you may able to check with the pre-available and that template tools, right, for different products, so that you can have some understanding. Okay, for our product, what kind of inventory that we need to come up with, right? So for this sample exercise, I have been showing this to you, right? So likewise, you may have some understanding. So this is now you will have some clear understanding for a construction product typically, right? Especially the block and the tiles, for all these things, right? So let's go into the next stuff in the tool. So whatever you build newly, that will be shown here, and the life cycle also, it will be shown here. So when I click in the left side, the products, it shows whatever the product that I created, right, and the date, all those things and all. Then in life cycles, you can see what all the life cycles have been created. So now you may ask, So why they provided the distinctive things, products and life cycles? Because sometimes you may go for product carbon footprint. With respect to product carbon footprint, mostly people are going for cradle to gate, right? So if at all the regulation or the requirement specifically mentions that the entire life cycle of your product has to be accounted for the carbon footprint of products measurement, unless otherwise the people typically go for cradle to gate only, right? So in that sense, so this particular software splitted that provision. Okay, you can go for the PCF project separately under the products, and if at all if you want to go for full life cycle assessment with full fledged of impact category means, then you can go for the life cycles, right? So what is the basic difference between PCF and LCA? So PCF governs by or governed by ISO 14067, which again depending on ISO 14044 majorly, along with 14064 and other relevant ISO standards. But what is the ultimate difference between LCA and PCF? In LCA, we cover broad environmental impact categories, right? So we can able to understand the impact on water consumption, and impact of air, and impact on human health, impact on environmental health, ozone depletion potential, acidification, and GWP. But in case of PCF, we restrict ourselves and we want to focus only on carbon emission, which means CO2 equivalent emission, which again are nothing but the total GHG emissions which comes out of a product during its A1, A2 and A3, right, which is cradle to gate. So within the CO2 equivalent, they will provide a subset. Okay, GWP total, GWP fossil, and GWP biogenic, and GWP land use, right? So for that you need to apply IPCC method to go for PCF. Whereas in LCA, apart from IPCC method, there are a lot of other methods which will give you different sets of impact category based results, right? So that's the basic difference between LCA and PCF, and this software provides you a distinctive route to execute the respective option, right? If you want to go for only PCF, then you can create product. If you want to go for a life cycle, then you go to the life cycle. So now we want to go to the life cycle. So in the left side we can see life cycles, and you just need to create life cycle, right? So what is the name we can give? Okay, AAC block LCA full demo. Okay, so here they are asking attach life cycle to a main product. If you are already created a cradle to gate entry, then you can attach, or else you can you just untick that. Then they will ask how many number of life cycles you want to have. If you click it, which product you want to attach, that's what they are asking. So we are not going to do that, and we just uncheck, and straight away see it here. Standard 5 phases, you see: production, packaging, transport, use, end of life. Then 3 phases: production, use, end of life, right? Standard 2 phases, only production and use, right? So likewise different template they are giving, and within EN 15804 they give a couple of options. So we just go into 15804 full split, so that the entire life cycle stages will be shown here: A1, A2, A3, A4, A5, B1, C1, D, right? That's what we are going to create. So the life cycle has been created. So which means you can see it here, the impact category for the initial indication GWP total. So it is 0, which means there is no inventory has been added yet. So under raw material supply, you see nothing is there, right? And I hope you can able to understand this. And now when you see your available inventory, which that already prepared, exactly follows the same thing, right? So before going for any software for the first time especially, you should understand how the software seeks the data from you. Is there any prevalent structure, so that it would be easier to use the software after making the entire structured inventory as itself is requiring, right? So I navigated the tool earlier couple of times and understood what kind of information it really asks, and at what kind of pattern or structure it asks. So accordingly, I prepared my inventory, and I have made a table thing. So that I don't need to go back to any of the background calculations, because I have done all of them, and I have put the final number here, right? So that's what I told. Once you open the software and do the thing, it would be taking more time, right? So your software will be opened and will be idled, right? So to avoid that, you just do all the background work and come up with the full inventory. Then you jump into the software, right? So now we are going to add one after another, right? So the raw material supply, aluminum powder, right? So under that raw material supply, I just click add item. I can see, okay, I think everything will be already there. So what it indicates, once you add something new, you don't need to you have to enter each and every information. So unit, whether it is inventory, normal inventory or waste inventory, what is the amount, right? What is the amount? Everything you have to add. So once such entry is added, that entry will be registered here, object library. In the left side you can see. Can you see that? All these 2-3 pages are there, right? So, or you can see it like this, which means the inventory that I created and used in my models will be bundled as an object, and it will be stored here, right? So what is the concept of this object? So if you are looking for monthly subscription, for the basic amount that you pay, they would restrict you to have only 100 objects per month. So which means such 100 inventory data you can create maximum within a month. Suppose if you want to add more, then you got to pay additionally. That's it. And for the instance, once you create one object and the same object is being used next time within the same model or some other model, that won't be considered as the additional object. So which means you created once and you can use it multiple times. That won't be considered or counted as a separate object. So in that sense, 100 objects you can use in a single month, right? In case of a monthly subscription. In case if you are getting a yearly subscription, then there is no limit with respect to the number of objects that you create for a single month, right? So since I have already created all these things, so when I type aluminum here, okay, PC block. Yeah, so when I just want to add and I type aluminum here, it shows directly, right? So I just click that. Can you see that? Right. So amount alone, it doesn't get updated, because amount may vary with respect to different life cycle, right? So now we see amount, how much? 0.331 kg. 0.331 kg. So I just click add item. That's it. So you may see the impact 6.72 CO2 kg CO2 equivalent. So is it automatically coming? No. What you have to do is you just click. You can see the background dataset has been already attached. How? Because the same object has been used in some other inventory or life cycle with the same background dataset only. So when I just select the previously created object, except the amount, it comes along with the previously chosen background dataset. That is the reason it is, once we just entered, it directly calculated the impact value. For the instance, let me go for AP, right? Same aluminum powder. So I kg, right? Then I put 0.331, right? So now I have created a product. Now can you see there is no number, instead it is showing add impact or add item. So we need to attach the background dataset freshly, right? Add impact. Now this is the background dataset. So obviously shown from Eco Invent, right? So here in this tab, we want to find aluminum powder. Yeah, here it is. So aluminum sulfate production, market for. So here you can filter geography, property and respective database, right? For the instance, if I want to make it for Asia, then I can go for the filter. Now you can see only Asia related aluminum production or kind of thing is added here. It's shown here, right? So liquid aluminum production, liquid concrete block, and for the data also, now you have the property as kg, right? So you go for kg based, mass based data set alone, right? And the database, obviously if you want to go for the 3.9, you can choose accordingly, right? So now from this list, based on the further information with respect to your life cycle, the model, you have to choose the respective background dataset. And if you want to understand more on each of the dataset, because you really want to know what are the impacts this particular dataset covers, so that I can make my choice. So if you just put the cursor, you can see view. If you just click view, it will provide you the entire information about the particular dataset, including the geography, the temporal coverage, right? And what are all the inventory goes into this particular dataset, right? And if you want to understand more on the same dataset in Eco Query, you can click here. You just click here, it will go to the Eco Query page where you can have more detailed look into that respective same dataset. Can you see it here? Yeah, right. So that's how it will be. And if you want to choose this particular data set for your the element, then you just click OK, add. That's it. Now, yeah, so here they will ask what is the property, whether you want to go for 1 kg. Yes, it is for unit mass, the impact will be go there. So here we define 1 kg, there is no change with that. But with respect to the inventory, we will provide what amount of kg of AP that we need to account. Right here, can you see that it is 9.55. Same inventory, same aluminum powder, but different data set gave 6.72. Right. So what is that data set? Aluminum ingot, primary, import from Oceania. Oceania, I think it is Australia and New Zealand, I think. So why it is imported? Because my particular inventory, I did not mention it here as it is imported, but it is actually imported stuff, imported the raw material, right? So I chose that particular data set, right? Import from, right? So here once I choose the relevant data set, here I can choose which life cycle this particular stuff belongs to, A1. Okay, then what else? Then nothing, you don't need to worry about anything else. If you want to add any of your personalized description for each of the data set, you can mention it here, because at the time of LCA modeling, you might have some justification with you why you particularly chose that particular data set, but over the time you you would forget it. Sometimes it happens. So just to keep that tracking, you just describe here, okay, this is the reason why I chose this particular data set. That doesn't come in your result, nothing, but when you open the model and you click each of the data set, you would understand the justification or decision making went behind that particular choice, right? So that is it, right? So now what we are going to do, we are going to delete it, because this is just a dummy data set that I wanted to show you, right? So how it will be looking when you want to add anything newly, so that for each of the entry, you click add impact and go to the background dataset directory and choose it from there and add it. That's it. That's the process. So now we are not going to do that for all the inventory. We are just going to add it, right? Second one is cement, right? So we are just putting cement. Yeah, here it is, cement. So what is the inventory amount? 1.65 plus 2 means 165, right? 165 kg, right? Yeah, so the cement comes with the maximum impact, right? So you can click and check what data set was chosen. Cement production, Portland, simple, right? And it is from a local supplier, right? That's it. So now, so once you add it, everything will be auto saved. That's it. You don't need to click save or nothing, because it's real time, it is being saved. Likewise, the next element, desert dunes silica sand, right? Desert dunes silica sand, right? So when, remember once again, when you do it for the first time, nothing will be shown up. You create everything from the scratch. Since I have already created all these things, it is being shown up from the object library. So I just select it directly, right? I hope you can understand that. Okay, then 4.78 means 478. Okay, 478. Yeah, desert dune has been added. Now quick line. Okay, quick line. Okay, here it is. Quick line. What is the inventory? 16.5. 16.5. Yeah, here it is. Then water 397 kg. So in AAC block, typically the water is very important, right? I think two objects are there, so we have to be cautious which one it is coming from, because with respect to AAC block, the water is one of the main ingredient, right, in concrete block production. So it comes under A1 module. Normally the water, electricity and all would be coming under manufacturing, right? But this particular product necessitates the water to be added in raw material, because it participates significantly in the mass balance scenario. So what is that? 397 kg. Okay, 397 kg. So when I just added that, I just want to understand what data set. Tap water production, seawater reverse osmosis. Okay, fine. So if your utilization of water comes from the RO, then that has to be chosen. Since my product has that background, so I chose that, right? Then what else? That's it, I think, right? So only 5 raw materials, that's it. So we have added A1, right? Now under A2, transport, upstream transport, right? So for each of the same raw material, along with couple of packaging material, we have to add the transport, upstream transport, right? So transport of additive, that is nothing but aluminum powder, right? So you just name it transport of additive. Okay, what is the inventory? Inventory here, it is in ton kilometer. So 0.833. Oh, sorry. Transport of additive 0.833. Add item. That's it. So what data set has been attached? Market for transport, freight, aircraft, because it is imported. I already mentioned the aluminum powder, so I chose the aircraft unspecified, right? So accordingly imported via air I mentioned here. So I again assign the EPD module or life cycle module to this particular data entry. Okay, it is A2 transport, right? Likewise, I just add transport of cement. So here you should understand how the number calculated, that 2.001 means 20 ton kilometer, isn't it? Yeah, 20. So let us just check, or let me explain. So your data sheet should show the distance it covered for bringing up the particular raw material. For the instance, for the cement, right? What is the weight of the cement that you used? 165 kg, right? So when you convert that 165 kg into ton, right? Kg to ton, right? US ton, no, metric ton. Okay, yeah. So 1 65 kg. So 0.165 ton is my mass which is transported to some x distance. For the instance, if it is some 100 kilometers, means I have to multiply 100 with this mass. That is why the unit of your transport impact is ton kilometer. Right, so that transport inventory has to be provided in ton kilometer, because based on the mass, you may think why ton is being added, why not only the kilometer, because it is only the kilometer, right? Because why? Because with respect to the mass, the respective associated impact is affected. For the instance, if you are for this case, we are just transporting 0.165 tons of cement for some 100 kilometers. There is some emission or impact values, right? And if this tons is increased to 5 tons instead of 0.165, if it is 5 tons, means the same vehicle has to spend more amount of vehicle so as to pull the vehicle. Can you understand? Which means run the vehicle, more fuel is consumed, more emission is released, and more impact is accounted. So with respect to the transportation, it is always the mass is getting attached, so that only we come up with ton kilometer as the unit. So in your typical data sheet, you will have mass separately under A1 and distance traveled under A2. So you just need to multiply that to come up with the final number. So here the respective final number for different thing is, this is it. So that only the unit is very clearly mentioned, right? So that's how the background calculation might have been went, right? Okay, cement we added. Next, PP strap, which means polypropylene strap, which are used for the packaging, right? So transport of PP strap. So what is the amount? Obviously PP strap would be very least in weight, so 0.00187. 0.00187. Yeah, right? So I can see it is very minimal. So when I see the attached thing, okay, lorry, diesel unspecified, okay, nothing, no issues. You may ask, okay, you added the material under A1 and adding the A2, the transportation under A2, but you straight away added what to say, the packaging transport here, but you did not mention it in raw material. You may have that question, because that PP strap doesn't come under raw material for my product, whereas it will be only coming under packaging material, which I would add under A3, right? So that we did not add it under raw material. And since we are following that life cycle stage wise modeling, this is why it is happening like this, right? Then we have quick lime, transport of quick lime. Transport of quick lime. Okay, what is the amount? 0.186. Okay, 0.186. I just added it, right? So when I just click the background data set, I can see, yeah, market group for transport. All are same. Everything is land transport and local, right? So almost same data set has been attached. Then transport of sand. Sand. What is the inventory? 57.6. 57.6. Okay, quite higher transportation impact. What is the because you see 0.478 tons, the distance might be more, right? So more than some 100 kilometers or 120 kilometers, so that the final multiplication number comes that much, 57.6, right? Then transport of wooden pallet, again this is the part of packaging stuff, right? Transport of wooden pallet. What is the inventory? 20.3 ton kilometer. 20.3. Okay. Yeah, that's it. So it should be 7, right? 3, 6. Only 6 is there. I think we missed one. Okay, for water there is no transportation, right? That's why only 6. Okay, so now we have modeled A1 and A2. Now we are going into A3, right? So for A3, electricity, fuel and packaging material, right? Normally water would be there, but since the nature of the product demands the water to be in the raw material, we added already in the A1, right? So electricity we have to add. Okay, electricity. Okay, so what is the unit? Kilowatt hour. So what is the value? 1.30. 1.30. Okay, there it is, right? What is the data set? You can see market group for electricity, low voltage, right? So typically for a factory setup, it should be high voltage or medium to high voltage, depending on the size of the factory and what are all the process that are involved in that manufacturing plant. So typically if you see AAC block, for that the autoclave purpose, obviously more amount of voltage would be there. So I think it would be a high voltage should be preferred, but still I have just chosen this. So if you want to change that, you can change that, right? So how to change? You just right click and here it is. That's it, right? You just search for it. So this is where you take more time. So finding the appropriate background data set with full proper justification only takes more time, right? So we just added the electricity. Then here for fuel, next fuel megajoule, right? Okay, let us put fuel. Yeah, fuel for manufacturing and fuel. Okay, fuel for manufacturing, megajoule. What is the value? 6.49 plus 2, 649, right? 649 megajoule. So sometimes the fuel, your data might be available in mass, but the background data set with respect to the relevant geography and the temporal regions might not be available for mass. Instead it would be available in megajoule. So at that time you would need to convert your data to that available data, or available data to the your existing data. So sometimes you would need to do that, right? So fuel for manufacturing strikes very high. We can see that diesel burned in diesel electric generator. So you may wonder why you just added this data set. Can you see that? Because for fuel, based on your data inventory, what specific fuel it is, you would know whether it is petrol or diesel or any other, oil, LHVs, a lot of things are there, right? So which nature of oil or fuel that you use, you would know. And when you search for the relevant data set, sometimes what happened, you would attach only the production based data set for the respective fuel. For the instance, especially for this model, when I was doing it first time, I attached production of some gasoline or kind of activity I attached. But when I checked it later, I realized that the particular data set was not complete. What is meant by complete data set? Because when you add a particular data set, especially here the fuel, under manufacturing stage, not as raw material. I don't think where the fuel will be considered as a raw material. Maybe in some refinery process it might be there, but here the fuel is being considered as manufacturing requisite, which means the fuel is going to be burnt, and because of that burnt energy, some manufacturing related process is going to happen. So when I attach the production related data set, that lacks of combustion related impact. It just comes only with production related impact of that fuel. So what I chose early, it was only production based impact. Then I later realized and understood, okay, now I want to find another data set which comprises of both production and combustion impact of that particular fuel. So in that case, I could able to find only this data set, that diesel burned on diesel electric generator set. So you may wonder, it is generator set, DG set, how you can add it? Okay, it's not available. So I chose the proxy one, right? So it now covers both production and combustion related impact of that particular fuel, right? So that's it. So we added the fuel. Then we want to add the packaging material, PP straps and wooden pallet. Now it comes, right? PP straps. Okay, what is the amount? 0.157 kg. 0.157 kg. Okay, it has been added. Likewise, wooden pallet. So wooden pallet. So item, so which means unit, right? Not in kg but in unit. So 0.505, right? 0.505 unit. Because sometimes the full pallet meant for 1 meter cube or couple of meter cube of AIC block coverage, but our LCA model goes for 1 meter cube of AIC block. I really sorry. Now only I declare that the functional unit or declared unit for this LCA model. I should have mentioned it very earlier, right? So this entire inventory prepared for 1 meter cube of AIC block, right? So since that 1 meter cube is our declared unit, but the typical wooden pallet available in the data set covers more than 1 meter cube. So accordingly we scale down our typical requirement, so that only it is coming as 0.5 items instead of in full numbers, right? So now you can see when I added the wooden pallet, it is showing negative. So what is the data set exactly? market for EU or flat pallet, it impact itself minus 26.66 kg CO2 equivalent per kg of the material. Since we added half of the item, the 13 is coming up, right? So what is the indication of this negative? This particular material sequestered some amount of CO2. So whenever we added any other activity or material, we see positive number, which means that much amount of CO2 equivalent emitted. But when we see negative, that much amount of CO2 equivalent sequestered. There might be lot of reasons, and very primary reason for this minus 13.46 for the wooden pellet is because the wooden pellet is a biomass, right? So there is a separate concept called biogenic carbon and respective accounting in LCA, right? So that and all are a very big topic, right? We are not going to talk about them in detail here, but still, what you should understand is minus sign comes because that much amount of CO2 equivalent has been sequestered into that product, right? So the data set comes with that information. So based on our amount value, the final impact is being calculated like this, right? So once again I show the background data set. You can see the wooden pallet comes with minus 26 kg CO2 equivalent. So when you put 0.05, it becomes 13.46 kg CO2 equivalent, right? So I just add the respective life cycle module A3 manufacturing, right? So now we just added all the information for manufacturing. A3 completed, right? Now the downstream transport A4, but we did not include, we are not going to include that, we are just going to exclude. So depending on the type of EPD that you go, especially in the EPD project, you may include or exclude, right? Yes, but still for the sake here, we may add the downstream transport also. So you may think, what are all the downstream transport? Just like how we did upstream transport, the same way downstream transport will come. No, here is the difference. All these upstream transports contributed towards the manufacturing of one AAC block with all these ingredients, isn't it? And packaging material. So when we go for a downstream transport, it will be only one transport, not again all the individual raw materials, right? So because in the downstream we take the finally produced AAC block to the concerned location, right? So let us add that, right? Transport of, okay, let us put transport of AAC. Can you see that there is no such object is already available because I did not create earlier. Again, it is ton kilometer inventory. So here it is. We should know. I told already it is 1 meter cube of AAC block, right? So 1 meter cube in the sense, what is the mass for 1 meter cube? So that may vary depend on the particular AAC block, because in the market the AAC blocks are available in different densities from 100 kg per meter cube to 600, 800 kg per meter cube, right? So that value we need to calculate here the respective transport and possible maximum distance that you sell your product to your clients, right? For the instance, you are located in a particular address, and from from that address only the AAC block is being manufactured. So keep that as a center, and you draw lines or stretches to the different locations to which you supply your product, right? So if you take 100 kilometers in one direction, 50 kilometers in another direction, 80 kilometers in another direction, means then let us take the maximum distance 100 kilometers, right? So now that kilometer is 100. What about T, ton? The density value of your concrete block, let us assume 500 kg per meter cube. So what is the ton? 500 kg means 0.5 tons multiplied with 100, right? So 0.5 multiplied 100, 50 ton kilometer. So here you just put 50 ton kilometer and add, right? So now you see there is no impact because this is a newly added object. So we have to find the respective background data set. So we put transport, right? Freight. Okay, I just put it. I think no result. Some spelling mistake might be. Okay, I think. Okay, or to put lorry or what as a keyword? Yeah, lorry, and yeah, it is transport. Yeah, here it is. So you can see different property, ton, kilometer, sometimes mass. So we just mass and distance, which means good transport, right? Goods transport. And the geography, if it is Asia, nothing, right? So obviously we need to go for global average data set, right? And you will see lots of options. Transport, lorry, refrigeration. Can you see that? Refrigerated supply chain. So where that refrigerated supply chain would be preferred for pharmaceutical or some food products, right? Because they have to be freezed or frozen, right, until they get supplied at the end. So in that sense, more impact will be coming, because along with the transportation based emission, you come up with that GHGs from that refrigerants, coolants, all those things also, and respect to additional electricity consumption also. For the refrigeration you need electricity, right? So it will be more impact when you choose the refrigeration based option, right? So we don't need refrigeration here in our case. So we just need to go down. Okay, everything is refrigeration. Okay, no refrigeration. Yeah, here it is. So we can see market for transport freight, lorry with refrigeration. Okay, here it is straight away. Yeah, market for transport freight lorry, unspecified freight lorry, rest of the world. Okay, so either we can go for global or rest of the world data set, right? So I just chosen that one, and they're asking, yeah, it is 1 unit, right? So now we just added a new element A4 also, right? So we just need to clarify it here in this life cycle thing. Okay, yeah, it is A4 transport to site, right? That's it. Now once it is transported, what happens? The installation requirement will be there for the AAC block, isn't it? So that's what here we are going to add. So for the installation we need mortar, we need water, isn't it? And you can see it additionally, transport of wooden pallet. Why it is here? So in this particular case, the delivered wooden pallet is taken back to the site by the manufacturer. So in that case, we consider the return transport from the site. So that only the particular inventory is there, but anyhow we are not going to add that in our typical demo, because that would not be the usual case everywhere, right? So once the product is delivered to the site, the respective packaging material will be go to the end of life stage, the C module. In the C module you have to add all those things, right? So you don't need to worry about that. We are just going to add the lightweight mortar. Yeah, lightweight mortar. What is the amount? 40 kg. Yeah, 40 kg. Yeah, here it is. Then we are going to add water for mixing, right? Water for mortar mixing. Again, liters, in terms of liters, 8.50, right? For 1 meter cube of block, wall construction, right? Yeah, that's it. Is there anything else? No, right? Transport, okay, fine. Now we completed the entire A1 to A5, right? As I already mentioned, the B module we are not going to model here, so we just delete them, right? Yes, you can delete or you can keep it, the result won't show up there, that's it, right? So we are now entering into the end of life modeling, C1 to C4. So in C1 to C4 we have the sequence of activities. As you can see it here, first what happens, C1, deconstruction or dismantling of your product happens. So for that activity, sometimes it would be done manually, or sometime it would be done with some machines and other things. So respect to energy consumption would be there. Sometimes based on the nature of your product, there won't be any impact comes out of the C1, because as it is, the product becomes waste, it can be transported straight away to the waste processing. There you don't need to separately dismantle or something like that, nothing, right? For the instance, the smartphone as an example, right? So normally when it becomes waste, we just throw it out, right? And it has been transported to the waste processing. We don't do any dismantling or nothing, right? Right, it's not recovery. You should understand the difference. For the example here in our case, for AAC block, the block is becoming a part of a building, and throughout the use phase, say 30 years or 40 years or 50 years, it is staying there. Once the entire building becomes out of use, the building is getting demolished, right? So straight away the building cannot be transported and dumped in the waste processing unit, right? So that is not possible in this case. So there is a dismantling or deconstruction is happening, right? So it is based on the product that we deal with. Sometimes the C1 will come, sometimes the C1 will not come. So here the C1 comes as deconstruction. So for the deconstruction, how I can understand the respective consumption of energy or material? So whether I need to come up with these data on my own? Yes, definitely. But still, you can refer any PCRs which are available under EPD International or ACLC, as I previously mentioned. So you can refer them and you can come up with your own data for your scenario, or you can simply adopt them, right? So here I just adopted whatever is presented in EPD International, the main PCR for construction products. So they provided a complete table of information. Okay, I can even show you that, I think. because that is very crucial, right? Because people may wonder, so how I should come up with my end of life inventory for my construction product. So you just go to the EPD International website, you see PCR library, so that you can go into the EPD portal, right? So you just need to log in with your some personal stuff. Right, so here you can see the PCRs. Okay, I will just click PCRs. You can see the library. Okay, product category, construction product. I just click search. So here it is, the version 2, and if you just click it, it will open and let it get loaded. Yeah, so since I have already used mostly, it shows, yeah, here it is. So the default data for modeling modules C1, C2, C3 and C4. So they referred it from some external resources and provided it as it is, right? So this is what I referred and adopted as it is. So what they given for C1, C2, C3 and C4. C4 is simply the landfill. But the C1, C2, C3, various construction products will be there, right? For the instance, they gave some different categories: concrete, RCC, masonry, tiles, steel, wood and other materials. So our product is AIC block, that is masonry product, right? So I referred this particular number, okay, diesel consumption for dismantling of my masonry unit, quantity kilowatt hour per ton, right? So now for our AIC block, the mass is 500 kg per meter cube, which means the value of that 500 kg has to be converted into ton, and for that much ton, what is the kilowatt hour? As per this data you have to calculate. So for 1 ton 5 kilowatt hour, for half a ton obviously 2.5 kilowatt hour, something like that it would come, right? So likewise you have to calculate for your given product based on the values shown here, and that is how I developed this inventory, okay, C1 to C4, right? So I think it is clear. So we are just going to add it, right? Yeah, here it is. So the C1, first thing is deconstruction, right? Yeah, diesel for deconstruction. So what is the value? 10.8 mg, right? 10.8 megajoule. So yeah, here it is added. The next thing is C2, that is transport. Once the deconstruction is done, the waste is getting transported, right? 48, transport of debris, right? So of debris, here it is 48. Then C3, right? So C3, 3 different activities are there. Everything is from that EPD only, you can refer there. So crushing of blocks and loading and unloading sorting facility, mechanical sorting. Actually it is shuffled. What would be the first activity? Loading and unloading at sorting facility. So the transported waste is dumped in a treatment or processing plant. Within the processing plant, the quantum of that deconstructed AIC block is taken up and poured down. That is what is mentioning loading and unloading at the sorting facility, right? So for that, some amount of electricity or energy would be, fuel based energy would be consumed. So that is the first thing. So after loading or unloading, the mechanical based sorting will be there, right? Then it may be getting crushed. So maybe the sorting would be happening first, or the crushing would be happening first, right? I think crushing would be happening first, right? So, or maybe depending on how that facility is designed, the respective sequence of operation may follow as it is, right? So these are the three typical activities that are expected to happen at waste processing site for AAC block, right? All the three of them we have to add, right? And you can see, C2 is attached, C2 transport to processor, right? Sometimes people think in the C3 recycling is happening. No. So what exactly happening in C3? It is just waste processing. So the outcome of the waste processing will go for its final destination, either landfill, either recycling, or either incineration, right? So that is what normally happens with respect to these different life cycle modules. Sometimes the C3 comes with the incineration also. Here you can see, right? Sometimes, right? Where it is? Yeah. So in the process C2, for products materials not to be incinerated means 80 kilometer. If it is to be incinerated means 130 kilometer, right? But in the processing of construction product, there is no incineration, right? So I understand this way, that in C3 only some pre-processing is happening, and outcome of that pre-processing unit or activity will be directed towards either landfill or further recycling or incineration, right? So that's how I understand it, but we should not misunderstand it, right? In C3 all that different possibilities are happening, either incineration or recycling. No, it is not, right? Recycling would be happening out of this waste processing the thing, right? So yes, to understand these things more, we can have these descriptions, right, in the the PCRs, right? So what supposed to happen in what module, right? And D module we have specifically. So in the D module, right, the consequences for recovered material beyond the product life cycle. Recovered material in the sense, out of waste processing, we decide, okay, some quantity goes to the landfill because there is no use for them, but some quantity is looking good and promising, so we can do something with these kind of material. So I decide whether I want to do recycle or reuse or whatever it is. Accordingly, the module D comes. So in the module D only, we connect the recycling, right? We do the recycling, right? So we are just adding it. Waste processing, crushing of blocks. So as I already mentioned, you don't need to worry about the sequence, but it is good to have a clear understanding, right? 2.43, right? 2.43. Yeah, it has been added. Crushing, okay, done. then loading, unloading. Loading and sorting facility, megajoule. So then we have 0.990. 0.990. So what is the diesel is happening to be used in loading means, okay, I think I mistaken. 0.99 is actually for mechanical sorting, but not for loading and unloading. 2.92. Okay, 2.92. So we can directly change the number here. 2.92 megajoule. Okay. Then, so what is the ultimate purpose? Vehicle movement in that waste treatment facility, right? So for the vehicle movement, the fuel is being consumed, and that is what we take into account, right? Mechanical sorting 0.990. Then land filling and compacting, that is C4 ultimately, right? So here you should understand our AIC block has been processed. So the outcome of process, we have a choice how much proportion we want to take it to the landfill final destination, and how much proportion we want to take it to the recycling, right? For the instance here, our mass per meter cube is 500 kg. So that 500 kg cannot be directly benefited into the recycling stuff. But with respect to the AIC block, how it will be ultimately go to the next product system. Once it is crushed, that's it. It can be directly used in the newer product system. For the instance, I am manufacturing sand means the AIC blocks, once they are crushed, that's it. They can be directly put up into the manufacturing unit of sand, right? So that's the way this product facilitates the recycling. But depending on the different other product, post waste processing, you may need to subject the product for some additional processing in the name of recycling. So out of that recycling, something comes out, and that much amount of the recycled content only goes to the has to be accounted under D module, right? So with respect to this AIC block, so once we cross that C3 processing, our outcome is directly available to replace some virgin material in some other product system, right? So mostly the crushed blocks would be preferred to be used in sand manufacturing, right? So our quantum of the outcome from C3 is directly going to replace some virgin material in the sand manufacturing, right? So some proportion goes to the disposal. So we not always say, okay, 100% of my treated product is recycled, even though if it is having a recycling potential. So we can't say or assure, okay, 100%. So your proportion should reflect the probabilistic reality of the current market, considering the locality that you have, right? So for the instance, if you take UK, there may be the recycling behavior different from India, right? From UAE, typically saying. So where the manufacturer is located, accordingly the typical proportion for recycling to landfill has to be decided, right? So here in this case, I decided 25% of my processed AIC block goes to landfill, whereas 75% of my processed AIC block is eligible for D module benefits, right? Because for my AIC block, there is no further recycling activity, right? So for the instance, if you are talking about a cable product, so for a cable product, there is no deconstruction or dismantling. Once it is getting wasted, you just cut which part of the cable you want to dispose, you cut it, dispose it, that's it. Straight away sit into C2 and goes to the C3. So in the C3, and there may be some manual unwiring, cutting off that plastic and copper separately. That's it, pre-processing. So outcome of that pre-processing, you have two products: plastic, the covering, and the copper wire. So now you treat them separately for your potential recycling. You may consider, okay, in my cable product, I want to recycle the copper wire, whereas I want to incinerate the plastic hood, which means the plastic cover. So there accordingly the mass you have to calculate, and you have to model incineration in the C4 or in the any other D1 or D2, and accordingly you just go with the further D module benefit. So I think I mistaken at the end you do the recycling and take it the final mass to the D module benefit, right? So that recycling you have to calculate parallelly, but that won't be shown in the model. So post C3 processing, we straight away go to the D module benefit, right? But in the LCA report, you have to show that pathway. Okay, from the C3 module, this is my outcome. Okay, copper wire so and so weight, plastic cover so and so weight. So the copper wire goes to the recycling, and this is what the projected inventory happening in that recycling, and outcome of that recycling stuff. Now, because the copper wire straight away cannot be put up into some manufacturing of copper wires, right? If it is being facilitated, it is fine. Sometimes the recycled copper wire would need to be prepared into certain forms, like how the plastics are recycled, granulates, right? So the recycled waste plastic products are converted into granulates, and those granulates only further transported and used in the raw material production of further plastic products, right? So that granulate production normally we don't cover in C3. That we do it separately, and we just need to come up with the final quantity, how much mass comes out, right? Right? So that is what you have to show in your model as pre-processing, right? So then the final mass goes to the D module. Okay, this much amount of plastic waste is being replacing the virgin plastic, right? So so in C3, with respect to this product, I see that the AIC blocks, once they are crushed, they are straight away go to the D module benefits, right? So I still have some kind of a blurry understanding here, because so far I have strongly mentioned that in C3 only processing is happening, waste processing is happening, but not the recycling is happening. Yes, so while I keep on saying it, I have the clearer understanding. Yes, so in the D module, you have to model the recycling impact, right? So then only you come up with the final possible loads and benefits out of your recycled product. Yeah, now it is clear. Okay, let me show that, right? So we just added all the C1, C2, C3. We just need to add the C4, land filling and compacting, right? Land filling and compacting. So this is why, you may ask, you have already done it, but still you are you are not sure while you are doing it now. Yeah, it happens. So I sit lot of time, and I spend a lot of time while I was actually sitting and doing all these things. At that time, I completely into that context, I understand them correctly, then model it. But still, after a weeks of time or a months of time, when I completely detach from that context and do some other work, and when I come back, I have that blurry point again, right? So that is the reason, right? So in land filling, what is the inventory? 0.864. Okay, 0.864. Yeah, so we just added C1, C2, C3, C4 all together. Now in the D module, what has to be added? For our case, recycled AAC block matrix, which is in this case the outcome of C3 straight away. There is no further recycling need to be done on the crushed blocks. Sometimes, depending on since our potential the new product system is sand manufacturing, so we don't need to treat it any other way. The crushed AAC blocks are enough, right? But sometimes if you are about to produce aggregates out of your crushed AAC blocks, then in the D module, in the recycling, you may do some washing, chemical treatment or surface treatment, so as to convert the crushed AAC blocks into a potential aggregate, right? Aggregate production or aggregate directly, right? So it's up to the LCA practitioner what new product system I want to consider for my recycled product. Again, that should be closer to the probabilistic realistic condition in your locality, right? So for the instance, you can't come up with a whole new novel new product system for your proposed recycled content, right? So it's not at all there in the market. Then how you can claim, okay, right? So it should be there at least for 10% activity, 5% activity. It should be there in your local market. Then only you can adopt that as your new system product for D module, right? So here we chose I chose sand production, right? So accordingly the recycled AAC block, that is the outcome of C3 processing, goes into the virgin material replacement, right? So it is getting the benefit, right? So we can get it here, the benefits beyond system boundary, recycled AAC block matrix, right? Then benefits beyond system boundary, another one, reusable PP straps. So in case the PP straps, if it has to be recycled, means you can go for the recycling. But in this case, I am going to reuse it. So straightly, that is my benefit. That the quantity of that PP strap is my benefit. Then load. For this recycling, I have to take the crushed AAC block to the sand manufacturing unit. That transport comes. The transport of recycled AAC matrix. Then again, for reusing the PP straps, I have to transport the removed PP straps from my packaging to the actual PP strap production unit. So that transport impacts are added so as to account the additional impact with respect to the recycling or reusing, right? So after adding all the benefits and loads respectively, you go with the cumulative calculation in the D module, right? So here you may able to ask a question. Our concrete blocks density is 500 kg per meter cube, as we mentioned earlier. So once it is getting crushed, all the 500 kg can be replacing your, the virgin sand? No, there would be some quality degradation, right? So there, out of 500 kg, you should come up with the acceptable degradation based on some research, research in the sense, literature review and other textbook regarding, and other EPDs, obviously, right? Other LCA reports or industry reports, that if you crush 500 kg of AIC block, out of that 500 kg, how much amount of mass can be really used in the virgin material replacement, right? Okay, I took 60%, because 40% goes as unsuitable in the process of recycling or crushing, right? So I convert from the 500 kg, 60% only goes to the D module, right? So that the respective number has been calculated. Because so far we have the direct data with respect to A1, A2, A3, A4, A5, everything. Then once we enter into the C module, we refer the data from the EPD, PCR. And for the D module, you should know the data, right? The numbers. That is how you come up with the number, right? So reusable PP strap, you have that PP strap, the quantity, right? So here it is, you see the PP straps 0.157. The same thing is being mentioned here as 0.160. So both are same, has to be same, but while entering the number, it becomes that, right? But it has to be same, right? Because I don't subject the PP straps into any crushing or something, nothing, right? I don't put it in the waste processing. I just keep it separately and I straightly transport to the new PP strap production unit. So the mass remains same, right? When the outcome of C3 goes to further recycling, right? Or during the C3 processing, some reduction of quality would happen. So that has to be accounted. You can't simply say that, okay, outcome of my C3 is as it is the before disposed quantity, right? If I dispose 100 kg of my cable, when I want to replace, you can't replace exact 100 kg, right? Something gets lost in the process. So that has to be accounted, right? So in the benefit, I am just adding it. Okay, what? Recycled AAC block matrix. Okay. So what is the quantity? 270 kg. 270 kg. So please don't ask 500 kg out of 60%. It is not 270 or something like that. Here the mass, the density would be something different. So I just said that 500 kg as an example to you, right? So accordingly, you just need to calculate the D module, right? Can you see that? The D module, when I entered, it shows negative. Why? Because that is how it should be, which indicates here at the bottom most, you can see mass, I entered -1. Earlier, whenever I added something, I just keep 1 unit of kg or 1 unit of megajoule as it is, right? But here, when I want to put it in the D module, I make it as a -1, and that minus makes the entire impact negative. Why? Because that much amount of virgin material is saved because of my recycled AAC block. So as to convey that to the computer, I put the negative sign. Whereas earlier in the manufacturing stage, when I added the wooden pallet, it automatically came up with minus 13. It is different. When you added any biomass based data set for your inventory data, based on the nature of that biogenic carbon sequestration, it comes with the minus value, right? But here in the D module, I voluntarily tell it to the software that this impact has to be negative, so that will be taken as benefits for my recycled product, right? So similarly, I go for reusable PP straps. Reusable PP straps, right? What is the value? 0.160 or 0.157. Again, that is also showing the negative because I chose -1. Now what we should do, the load we have to add, transport of recycled AAC matrix. Transport of recycled AAC matrix. What is the amount? Ton kilometer 27. Right. Now you can see it is not showing the negative, it is showing positive because I didn't put it the negative value there. Here you can see it is 1 ton kilometer, the main property, right? When I click that, I put 1 only, right? Because even though you recycle it, you have to transport the recycled stuff, right? There would be some intermediate transport. Because of that intermediate transport, there would be some emission and respective impact. So as to account that, you put it as it is. So it is getting balanced, right? Similarly, for the transport of reusable PP straps. Reusable PP straps transport. What is the value? -2, 0.0160. 0.0160. That's it. Okay. Some quantity of impact because the weight is very low, right? That's it. That's the end of our modeling, right? So we just added whatever has to be added in the D module. So in the D module, you would need to do some detailed background calculations and come up with the final mass quantity and final recycling activity that would be required to be right. So they need to be added under benefits and loads. So if you whatever the activity you see as benefit, you put negative sign here. Whatever the activity you see as load, you just keep it as positive. So the negative values will try to balance with the positive values, and cumulatively under D module, what is the benefit? -5.87 kg CO2 equivalent is preserved or saved, right? Now you can see the entire thing, right? C and D module, right? And if you go to the next tab, you see it, right? So the total CO2 equivalent is 245. If you just change acidification, yeah, the number changed with respective value and unit, right? So for all, if you put biogenic, yeah, here it is, minus 17.7. Why it is biogenic carbon biggest in manufacturing? Obviously that is where the direct wooden mass comes, whereas in raw material in other stages the biogenic carbon comes because of some other non CO2 based biogenic origin or some other supply chain activities. So the respective biogenic carbon emission in those other modules are very least, whereas in the manufacturing straight away you use the biomass, right? So the value is higher. Likewise you can see then the table, you can see the impact, right? So the whatever the thing that you added, and it is only again showing for the biomass only. So let us put the total GWP, right? So that you can see the table differently, right? It's very least impact, and in the bar chart you can see the contribution, right? Can you see that in the D model you get some benefits, and because of the wooden pallet you get some negative stuff. That is what it is showing. Then in the donut chart you can see it in detail. Okay, what is the contribution, right? This is A1. Likewise you can see for the entire life cycle modules, right? So if you want to download, you can see it, download impacts, and it will be sent to your registered mail. Right? Yeah, here it is, download product footprint. I think the same page. Yeah, the product footprint will be immediately downloaded. This particular page will be coming up, and this is what you might have seen in LinkedIn. Somewhere people would be showing this as their activity, right? So AIC blog, LCA full demo, right? So the kind of thing. And with respect to the Excel sheet, that we need to open the registered mail ID, and there the Excel sheet would be mailed to you, right? So that's the kind of setup Eco Chain has. Anyhow, no issues. It will take some 5 minutes, maximum 10 minutes, so that here you can see it is immediately available, right? So the impact has been exported, right? So we applied 15804, right? So according to that, the result would be calculated. So you can see inventory tree for each of the life cycle stage, what are all the inventories added, how much added, and the respective impact in different impact category it is showing, right? So flat table, if you see, same thing, some different format. In case of EPD, can you see that? So life cycle stage wise, typically in the EPD you see these results, right? So you may wonder how they just arranged, whether the computer is generating or they are manually calculating. It is both, right? So you just ignore the B stage because we don't want to see that. I just delete them. You can see it here, A1, A2, A3, A4, A5, C1, C2, C3, C4 and D, right? And these are all the total impact categories for a typical EN15804. So how many indicators are there? You can see -3 means around some 45 indicators are there. So you have to split them into different categories: mandatory, optional, resource use indicator, waste indicators, and outflow indicators. So that's the typical kind of the setup you would see, and you can see the total and impact source also. This is the inventory. Now can you see this particular table was actually created from this sheet only. So you start with your own structured the data so as to facilitate yourself in the modeling, but this software exported the same entries like this, right? So for each of the data, right, what background data set you attached, that information is here, and what is the source and what is the geography, right? But along with this, I really wanted to see the year of that particular data set also as the additional information, because you would do this in a data quality assessment, that temporal coverage, geographical coverage you would need to mention. So at that time, if they are exporting the data set year along with the geography, then it would be more benefit. So I may send a mail to Eco Chain so that they can add it, right? So that's it. So now I hope you can understand how a typical life cycle modeling is done in Eco Chain from A1 to D, right? So in case if you have any questions in this model, you may post it in the comments, or you can always reach out to me through mail and WhatsApp, right? The same the D modeling, D module modeling would be different for the execution with respect to different LCA software, right? So that you should understand. If it is an open LCA, it would be different. In Simapura, it would be different, because you should understand the concept first, what you are modeling in the module D. So you are supposed to model not only the benefits but also the load, right? So normally people don't add the loads, they just go for the benefits and show up the positive minus number only. Positive minus number, you should understand, right? Minus number is always positive in LCA, because they are showing the sequestration or the reduction, right? So that is the only big crucial element in full life cycle modeling, right? If at all, if you want to add the use phase here in this AIC block example, you would need to additionally understand the PCR guidelines, because with respect to concrete product, what might come in the use phase? Nothing, right? Except one important stuff called carbonation, because what it suggested or believed that during the lifetime use phase of your concrete block, the inherent mass of the concrete block subjected to carbonation, and because of that it absorbs some CO2 from the atmosphere. So right, which means in the use phase you may come up with some negative impact positively, right? Negative impact positively, right? So that is the very important aspect with respect to the use phase modeling. Apart from that, you may go for some repair and respective additional patchwork materials requirement and some energy requirement, if at all, if you are doing any drilling and all those kind of repair activities or refurbishment activities. That's it. That's very typical, and there is not much stuff to seriously understand and follow up. But the carbonation effect is very crucial to understand. So if at all, if you want to include the B stage, then you should know more about the carbonation effect in the concrete elements during the use phase of the product, right? So that's it. That's the end of the session, right? So by this, I completely covered about Eco Chain Mobius in 2 different videos. One is the introduction to Eco Chain Mobius, where I spoke about the introduction of Eco Chain, their academy, their resources, their website informations, and their LCA products, both Eco Chain Mobius and Eco Chain Helix. What's the costing? What is the difference? Where to use what? Right? Then in the detailed the second video, yes, obviously this video, we have discussed and demonstrated how to model a full life cycle of a product A1 to D in Eco Chain Mobius. Right? Thank you.